this has the huge advantage of being code that I literally finished this morning, which makes it far more exciting. I sort of think of it as somebody's on the ledge and you're thinking, I'm going to watch this to see if he actually does jump, because it's very interesting to see how it turns out. So Alan, probably more than anyone, Alan Kay is my mentor. This is my favorite quote of his. Man is much more than a tool builder. He is an inventor of universes. That was in a paper he wrote called A Personal Computer for Children of All Ages, where the term personal computer was actually invented, coined. One of the reasons he's called the father of personal computers is because he came up with the term. But besides that, that paper described the future that you live in today. I'm going to talk briefly about sort of the historical perspective on this, and I'm going to talk about the stuff I'm interested in, which is this. But 1968 was the most important year in computer history. 5 things happened. 2 are less important. Intel was founded that year, and 2001: A Space Odyssey came out that year. But these 3 gentlemen did something phenomenal and are the reason we're in the room. And I'll talk a little bit about that. That's Ivan Sutherland on your far left, Doug Engelbart, and then Alan Kay. This is Doug, and unfortunately, the video I want to show for him is way too long for the time I've got. The thing he did in 1968 was demonstrated a computing system that you would be very intimate and comfortable with if you saw it. What was a magic was it was for the very first time that actually had been demonstrated outside of the confines of ARPA. It was the place where the mouse was unveiled. It was a place where copy-paste was unveiled, hypertext, and most important to me was collaborative computing, and that if there's a theme about what I'm after, it's that. Alan that year invented a thing called the Dynabook. Dynabook, he saw a 16 by 16 pixel display at some place, I forget where, and a 16 by 16 LCD display, and he realized that someday that will be as big as a tablet, and you'll be able to put a computer behind it, which is a crazy idea. But in fact, we live there, right? And look at that picture that he drew as part of that. These 2 children are collaborating. You look closely at the screens, by the way, they're sharing, they're collaborating. That was the whole idea of these systems. These are communication devices, collaboration devices. That was what's so exciting about them. And you probably heard this story, but I love this.
And they showed me really 3 things. But I was so blinded by the first one that I didn't even really see the other 2. One of the things they showed me was object-oriented programming. They showed me that, but I didn't even see that. The other one they showed me was really a networked computer system. They had over 100 Alto computers, all networked, using email, et cetera, et cetera. I didn't even see that. I was so blinded by the first thing they showed me, which was the graphical user interface. I thought it was the best thing I'd ever seen in my life. Now, remember, it was very flawed. What we saw was incomplete. They'd done a bunch of things wrong, but we didn't know that at the time. It's still, though, they had the germ of the idea was there, and they'd done it very well. And within, 10 minutes, it was obvious to me that all computers would work like this. And they showed me...
Stop. And what's really amazing is that he did leave the good things on the cutting room floor. Let's look at the last thing that happened in 1968, which was probably the thing people look at as the most important that brings us here today, but in fact is the least. And that's the head mount Ivan Sutherland built. By the way, my former boss built that head tracker on top of that. So I have a 1 degree of connection to this project, which is awesome. So obviously you can see I'm working in a 3D space. This is a system we're working on. I'm running in a browser. This is actually WebVR. And I'm going to just demonstrate some things to you on top of this platform to show you kind of what's really possible in a system like this. It's pretty clear to me WebVR is the real future of AR and VR. In fact, I don't even like the term. I think Clay Bavor came up with a perfect concept called immersive computing, which I think is what the only term I'm going to use from now on, because I think it really says what it is. They're all going to merge in a few years, and it's sort of silly to talk about the two as different. So I'm going to show you a few things. This is a little demonstration. This is actually intended to be integrated with the 2001 Indian population, whatever that thing is. Census, that's the word, thank you, stay there. Oh, come back here. And so it's kind of a fun little toy, but it's intended actually for a large data visualization thing. But I'm going to start getting into bigger things. So here's the US. Let me move him over a bit. And this is, you don't see anything, but what's really cool about this is you can see that data come right out of the screen. It's a huge amount of information that we're looking at there. And this is my favorite part, which is you just add water, and then you can watch Florida disappear. I'll put it back. It's not going to be quite that bad. It's going to be bad, but so one of the things, the reason we built this system was I want to be able to visualize very, very large data sets. And this one is really, really large. What you're looking at is a spreadsheet with 1,000 rows and 120-something columns. And running WebVR, by the way, this runs on my phone. I'll show it to you a little bit. But this is literally, the idea was, can we actually explore large data sets with data people already have? In this case, looking at Excel, for example. And in fact, this is intended to be a drag and drop interface for Excel. So I can change that color. Actually, I want to look up. See, it's really high. It feels like you're in New York. Come back here. And let's just say I'll change that there. So you can see it's pretty large. And by the way, this is something I've learned, is everything goes better with Perlin noise. So when you have this much data, I needed to come up with something, and so I just added Perlin noise to it. So this is actually dynamically charting the data that's right there in place. Now, another thing I can do, let's grab that and make a smaller version of it. So we can actually just interact with that as a smaller spreadsheet. Let's turn that around. And let's do it again, because that's kind of a fun thing to do. There we are. So what you're looking at is just this really nice tool set we've been working on with the main focus on data visualization. But I'm going to show you some things in a second that are even more interesting. By the way, just so you can just see the kind of a charting capability here. And again, this is Perlin noise data set, which is really fun for me to look at. I just love what Ken did here. So another thing that's really interesting about this, when you have this many cells, you can do something that you would never think of doing any other way. And hold on, go away. I want, I'll just come right here. I'm going to select about that. And what you're going to see here is really interesting. I'm going to zoom in real quick. You can see those numbers are between 0 and 255, which might be a little bit of a clue. But what you're really looking at is a picture. The cells are actually pixels, which really kind of shows something interesting here. Is like you take a regular old spreadsheet, and you can actually create a ray tracer where each of the cells computes that particular pixel. So I'm going to show another spreadsheet that's kind of fun. This is mortality rates. This is real data from the US government. This is mortality rates from US for males from 1900. And one of the things, since this is a VR system or AR system, you want it to like bend around you, so you can do that. And then what I'm going to do is select, let's say here to here, and then I'm going to extrude that out. And this very first line is infant mortality from 1900 to 2010. And what's really amazing, in 1900, infant mortality rate for males in the US was 14%. That's extraordinary. And then you just sort of see how it drops. It's still actually higher than other mortality, but that's to be expected. Another place to look is, oops, I don't want to go that far. I got to my glasses, sorry. Is 18 and 19-year-olds have an interesting challenge because they're the ones who tend to go to war. And indeed, what you're seeing here, this is World War I. This is the stock market crash. It's interesting that it had as big an impact on mortality as a war did. This is World War II. And by the way, this is an outlier. These are literally double what they should be. So every data set you'll ever see is wrong. It has some flaws in it. And then this particular one actually is right there. And it goes right across the line. So somebody did an equation wrong. And then here's Vietnam. So I'm going to show you one other thing. This system was designed in 2 layers. One is this large data visualization system. The other was the whole thing is intended to be a development environment. So I'm working with Y Combinator Labs with the idea of turning this into a super workstation. So imagine someday, and it's not that far, where any phone can be used as a programmer tool. And I want this. What I'm going to do is, this is just JavaScript code, right off the shelf. I'm going to drop that in there. And then I'm going to, hopefully that works. Yep. So, and then I can just do, hold on, 5, notch, up, and 10. Okay, 55. You can check my math. Or you can actually do stuff, I want that one. I'm going to grab this guy here. To the world around you. So you notice these little compass points around you. And what I'm going to do is just send a message to them. And just select, and do it. And oops, don't do that one. Do it again. Do that one. So here they are spinning around us. Every part of the system is accessible from within the system. By the way, this goes right back to Doug Englebart's system, where they programmed within the system to improve it collaboratively. So our goal is not just to allow anyone to have a super workstation in their head mount, in their VR, AR systems, but actually improve the system from within it. I built a system years ago called Croquet that enabled multiple people to do bit identical computation. We think we can actually get to the level we'll be able to do debugging inside the system like this collaboratively, which we think would be quite impressive. The other point to make here is WebVR is going to rule. We think we can get to 95% of performance when you consider WebAssembly and that sort of thing to what you get with native systems. But you have all the huge advantages of a system like this, where it's always accessible. You're not being prevented from creating content like you are on the iPhone. And one more thing, which is people are, particularly in certain areas, are getting smartphones before they get indoor plumbing. Wouldn't it be wonderful if we gave them the ability not to just be consumers of the content that we're talking about, but actually fully enable them to be socially part of the entire world? I think that's the big opportunity here when we see these technologies. You can think about them small and think, oh, we'll do better games, but the reality is these are fundamentally systems that allow you to communicate in a way we can't even imagine yet. We haven't even invented that, but we are beginning to see what the opportunity space is. And it all goes back to Doug Engelbart, Alan Kay, and Ivan Sutherland, who saw the future not only of the one we're living in today, but the one we're going towards. And that's the most exciting thing to me, is that the ribbon of history is in our hands. We get to decide where it's going to go. And since we have the vision from the past of those road marks, it's really a huge opportunity for us to make those ideas come true. And it's a real honor to be part of this. Thanks a lot.